Hello my fellow data miners. Today I'm going to show you a little video on how to do the chi-square test and a couple different ways you can do that. So if you look at this, I have some data on hair and eye color that I'm going to investigate and whether or not the two are related. So I'm looking to, see whether or not there's a relationship between eye color and, what hair color you have. So notice I have two categorical variables, so it's perfectly appropriate for the chi-square test. So the first thing I'm going to do is I'm going to do a little bit of investigation on my data, organize it a little bit into a two-way table or an association table or a cross-tabulation or a bivariate table. This has way too many names as you're currently understanding. So I'm going to go ahead and choose the cross-tabulation and chi-squared. This unfortunately is already set up for what I want, so ideally I'm just going to blank this out for now. So we have raw data in our table, so that's the one I would select for the roll down. And then my rows I'm going to choose to be hair color, and then for my columns I'm going to choose that to be eye color, so it's going to create that bivariate table for me. And notice I've got my counts selected, so I'm going to go ahead and select all of these so that it gives me like so much information it's not even funny. If I wanted all the percentages and whatnot for this, remove that real quick, and then I'm going to hit OK. And we did a table like this in class, or we will rather, because class hasn't happened yet. So as you look at this, it gives you three values in this box for blue eyes and black hair. So as you're looking at this, you might be wondering, what are all these values? Oh no! Well, that's coming off a bivariate table. So the first one is the count. So you look down here at the cell contents, and that tells you exactly what this is. So the second number is percent by row, percent by column, then percent by total. So the 33 is coming up from 1 divided by the row total, which is 3. And then the 20% is coming up from the column total, which is 1 divided by 5. 5. Which is 20%, and then this last one, the 5%, is coming from 1 divided by 20. So this is a lot of information. The other thing is this all column that shows up and this all row that shows up, those are the totals. So it's giving you the total rows that you normally see in data. Okay. What if instead you wanted to know the expected values? Well, you'd go into your cross tabulation chi-squared. I'm going to deselect a bunch of these because I don't really need them if I just want the expected table. If I hit the chi-squared button, I can hit expected cell counts and then hit OK and OK again. And it will give me the expected table for these values. So as you look at this, it's giving you what was expected for, blue hair, brown eyes, and all that if they were related. So this is the cross tabulation of that. All right, let's go ahead and do our tests. We're going to hit stat key. Oh, no, wait. Yeah, stat key. And then go over to tables. Notice there's this chi-squared test for association. That's exactly what we're going to do. Oh, determine whether or not the categorical variables are associated with each other. It describes it for you, so that's nice. Go ahead and remove this. So notice I have this selected as summarized data in a two-way table. We don't want that. We want raw data. All right, so eye color, hair color. Oh, this is already set and ready to go. Normally you'd select this and then your variables would show up and you'd select them in good times. So we're going to hit statistics. And I have that set to show a lot of things, so I think I'm going to turn some of these off. I don't want to see the marginals, I don't want to see the counts. So if you had all this selected, this would give you the expected counts, this would give you the full counts based on what's already observed, so just the totals from these. And then, the marginal just gives you that all column. I don't want to see any of that, I just want to see the chi-square test. You can totally select those and do the chi-squared test along with your tables all at once. It's pretty easy to do, it gives you a one-step process if you need all three. I'm going to hit OK, and then hit OK again. And now, it gave me my original data and its counts, which is kind of nice, and then it gave me my Pearson chi-squared as well as my degrees of freedom, and then it gives me this big old warning, because remember the one thing chi-squared cares about is you must have at least 5 observations for your data values. Oh no, and I definitely have less than that, so they're telling you right now, oh, this test is probably invalid. Aw, sadness. Okay, but, things. So the other option you can do is notice this didn't give me a p-value. It will most of the time, but since it thinks it's invalid, it's probably not going to. I'm going to go to my probability distribution plot, and that was the one way I can get the p-value. I'm going to choose probability view and click OK. And then normally this is set on normal, and so you'll have to select the drop down and go down to, or go over or up to chi-squared. Put in your degrees of freedom. Notice the degrees of freedom is given to you over here. DF is 9. Blunk. And then I got to tell it which shaded area I want. Normally probability is selected, but we want X value because we want to know the values that are greater than, or the probability that my value is greater than my chi-squared. So you want to choose X value, right tail, and then put in your chi-squared, which is that 5.016. 016? Yeah, I read that right. Okay. Let me click OK. Ooh, and we get a high probability. Okay, so as you're looking at this, remember, high probability means that, oh, it doesn't seem like I should reject my null hypothesis because it's a failure, you know? It looks like this is perfectly reasonable. Yay! So I would fail to reject in this instance, and there's my p-value. It's quite large. Okay, I'm going to go ahead and shrink that guy. All right, so I'm going to also get rid of this worksheet because I want to show you another thing. All right, so what if instead you were given a table, not raw data? How would you go ahead and do the chi-square? So this data is from a railway in Hong Kong that was trying to prevent people from committing suicide because, you know, statistics is depressing. Remember, we're trying to prevent death, so it's a good thing. So in like 2002, early 2002, they started installing these barriers that were called the, I can't remember what this is called, but it's abbreviated PSD. They're barriers to try to prevent people from jumping on the tracks. So when you look at this first data table over here, this is, you know, the number of people that committed suicide and like, if you total this, and as well as like whether or not they were experiencing some difficulties in their life. And then this is the data for after they installed the barriers. So these are smaller, but they want to see, did the barriers make a difference? Or is, you know, the psychology of it having a bigger effect? So we want to ask ourselves, are these two related? So this is the table we're interested in. So on an older version of Minitab, what you'd have to do is you actually have to select this. Since we're on a newer version, we don't have to do that at all. I guess I just selected it for fun. But instead, we go into Stat, and then we go into Tables, and we're going to choose Chi-squared test for association. So instead of raw data, like the lists that I actually have summarized data. Dun, dun, dun. Okay. And then this gets interesting. So you have to be careful when you're doing this. So I selected this because I want you to be sure that you're selecting the right stuff. I'm not using this table, I'm using this one. So I'm going to choose pre-PSD and post-PSD because that's the columns that have my data in it. And then I have to tell it where the row labels are so it knows where the rows are. And that was the column labeled disorder. All right, I don't need name category junk for that. And then I'm going to select statistics and turn on some stuff. So I'm going to ask it to give me my cell count and the expecteds. I don't care so much about the marginals, and give me the chi-square test. So I'm going to select OK, and then OK again, and here she comes. So there's my actual values versus expected for all of my values, or all of my variable outputs. And then here's my Pearson chi-squared, and in this case it gave me the p-value because it was less problematic than the previous, and then it notes to me that, hey, this might not be okay because I do have some cells with less than 5. Now, the reason why it was a little less unsure of itself here and actually gave me the p-value was because I didn't have so many warnings. So if this happens to you, you might have to go through and do the graphical version of calculating the probability, but most of the time it'll give you the p-value. The only downside is, notice it only is going to give you 3 decimal places on the p-value. So if you want something more accurate, like, you're going to have to go through and do the distribution version like we did here. Okay, so that was how to perform a chi-squared test on raw data, as well as two-way tables, or also known as contingency tables, or bivariate tables. They really need to pick a name for those. Have a lovely day.